Hello. I'd like to talk to you for the next few minutes about helicopter capabilities and limitations, things the helicopter can and cannot do. These are very important for you to know as the passenger. Subjects we'll cover will be the flight controls, we'll touch on aerodynamics, hovering in and out of ground effect, emergency procedures, weight and balance, and of course density altitude. Come on aboard. There are four primary flight controls. The first is the cyclic, flown with the right hand. The second is the collective on the left side of the pilot. This one includes the throttle on this particular model. And down below we have the anti-torque pedals. Through manipulating of these controls, the pilot is able to fly the helicopter. When the pilot moves the cyclic forward, this tilts the rotor disc the same direction. This redirects lift and thrust, moving the helicopter forward. As the cyclic is moved backward, the rotor disc tilts to the rear and the helicopter moves backward. The same is true for movement to the left and to the right. The collective, at the pilot's left side, controls the up and down movement of the helicopter. As the collective is raised, the pitch of the main rotor blades is increased collectively. More lift is generated, and the helicopter goes up. When the pilot lowers the collective, lift is reduced, so the helicopter descends. The throttle is also located on the collective. In turbine helicopters, the pilot uses this during startup and shutdown of the engine. A governor controls proper engine RPM during flight. At the pilot's feet are the anti-torque pedals. These control the thrust of the tail rotor. The tail rotor counteracts torque created by the main rotor and keeps the helicopter from spinning. The anti-torque pedals also provide directional control, left and right, when the helicopter is in a stable hover. When the pilot pushes the left pedal, the helicopter rotates to the left. The right pedal causes a turn to the right. Now let's talk about helicopter performance. A condition called ground effect generally improves the capabilities of helicopters. Simply put, when a helicopter is within 1/2 rotor diameter from the ground, it is called hovering in ground effect, HIGI. A cushion of air has been created between the ground and the helicopter, increasing lift and reducing power requirements, providing the surface is relatively smooth and level. Rough terrain, ridge tops, or pinnacles may reduce or even eliminate the advantages of ground effect. Once the helicopter exceeds the 1/2 rotor diameter distance above the ground, the cushion of air dissipates and you are now hovering out of ground effect, HOGI. To maintain a hover, the helicopter must now use considerably more power, reducing its effective payload. As you can see, the helicopter is much more efficient when you can use in-ground effect sites for your takeoffs and landings. And if you must use an out-of-ground effect site, the number of people or pounds of cargo you want to carry may have to be reduced drastically. A normal takeoff consists of bringing the helicopter up to an in-ground effect hover and translating the helicopter into forward flight. Additional lift is created as the helicopter moves from the turbulent air created from hovering to undisturbed or clean air in forward flight. This is called translational lift. Translational lift occurs at about 15 to 18 miles per hour. Translational lift will also be produced when hovering with a 15 or more mile per hour steady headwind. The wind blows the turbulent air away and provides clean air and more lift for the helicopter. This is why pilots prefer to take off and land into the wind. When the helicopter must hover out of ground effect, hoagie, to enter or leave a confined area, or to clear a tall obstacle without the benefit of translational lift, this is called a maximum performance takeoff or landing. During this maneuver, the helicopter is totally power dependent and margins of safety are reduced. So whenever possible, try and avoid these types of landing areas. What are the helicopter's capabilities in the event of an emergency? An engine failure, for instance? Engine failures in turbine helicopters are very rare. However, should one occur, a helicopter is capable of auto-rotation to a safe landing. A good thing to know if you're a passenger. During powered flight, air flows through the rotor system from the top and out the bottom. Helicopters have a free wheeling unit which automatically allows the main rotor to rotate freely if the engine fails or there is some other mechanical emergency. The rotor system then maintains flight RPM by reversed airflow. The pilot has full control of the helicopter during this maneuver, as I will now demonstrate for you in this practice auto-rotation. Here I have completely lowered the collective and removed all power to the rotor system. The helicopter descends rapidly at this point. As I approach the landing site, I ease back on the cyclic, raise the helicopter's nose, and slow the forward airspeed and rate of descent. Now, I level the helicopter, and using the stored up inertia in the rotor blades, I cushion it to the ground, completing the auto-rotation. Each helicopter model has a chart called the height velocity diagram. This chart shows the combination of airspeed and altitude from which a safe auto-rotation can be made. As you can see, the safest flying is done above 500 feet and at cruise airspeed. This is not to say, do not go low and slow. Just limit your flying in this area to only that is necessary to get your job done. Remember to assume the emergency position during any auto-rotation from any height. Now let's talk about density altitude and its effect on aircraft performance. Density altitude, by definition, is pressure altitude, or elevation, corrected for temperature and humidity. Air is said to be thin at higher elevations. That is, there are fewer air molecules per cubic foot at 10,000 feet than there are at sea level. Also, as air is heated, it expands, and you can get fewer molecules of warm air in 1 cubic foot than you can cool air. In effect, warm air is also thin. So, as you go up in altitude and temperature, density altitude also goes up. At lower density altitudes, such as sea level on a cool day, the rotor blades are moving through dense air, creating maximum lift at lower power settings. When the density altitude goes up, the air thins out. The rotor blades have less air to grab, and the pilot must increase power. Helicopter performance and capabilities decrease. So, during the warm summer months, plan your helicopter projects for early morning when the air is cool to maximize the performance of your helicopter. And when you add hover out of ground effect landings, or hoagie, to your project, just remember this saying: when it's high, hoagie, and hot, you may not carry a heck of a lot. Finally, we need to discuss weight and balance. At any given altitude and temperature, by manufacturer specifications, a helicopter can only carry a certain amount of weight. The pilot must determine this weight based on the current conditions by doing load calculation from his aircraft flight manual, prior to the flight. This weight, or payload, must not be exceeded. Accurate weights of passengers and cargo are an absolute necessity for the pilot to properly load the helicopter. Once this allowable payload has been determined, the pilot must then balance it aboard the helicopter. If you draw an imaginary line through the helicopter, at the middle of the rotor system, this is what is known as the center of gravity, or CG. To maintain the best and safest flying characteristics, the pilot has to balance the load on the helicopter. If the CG is too far to the rear or aft, the helicopter flies with a nose-up attitude. If the CG is too far forward, then the nose tilts down. In either case, control movements are difficult and maneuverability is decreased, not desirable if an emergency should occur. The same is true for lateral CG, or side-to-side loading. Try to keep all weight evenly distributed. If in doubt, ask the pilot where to sit or place and secure all cargo. I hope this program has helped you understand a helicopter's capabilities and limitations, and that you can use this knowledge in your future use of helicopters. Stay alert and enjoy your flying.